Okay, today we're going to talk about the classification of triangles. Before I get into the classification, I just really quickly want to go over some of the naming conventions we use for triangles and some of the annotation we put onto triangles. So when we're naming triangles, we can go either clockwise or counterclockwise. It doesn't matter which way you go when you name it. So I can call this one triangle A, B, C. I could also call it triangle ACB, CAB. It doesn't really matter the way we can show that with symbols, triangle A, B, C. And again, I can do any of those combinations that I just talked about. It could be CAB, any of those. So just real quick, other example. If I have triangle with D, E, and F on it, I can call this triangle DEF, triangle FED. It doesn't really matter. So let's try triangle DEF is what we're going to call this one. So that's how we name triangles. The other thing we want to go over is how we annotate triangles. So what I mean by that is you will sometimes see marks on triangles. These are called tick marks. If you see tick marks like this, that means that this side is going to be the same length as this side. So tick marks are used to indicate certain side lengths and the congruence between side lengths. So the other thing that we can annotate are angle measures. We use arcs for angle measures, and so if you see two arcs in this angle and two arcs in this angle, that indicates that they are congruent angles or they have equal measures. So again, on this one, if I wanted to say that all three of these are the same, I can even use two tick marks just so I don't get it confused with this one. I don't want people to think they're the same as that one. And I would do it on all three of the sides, and that would mean that all three of these sides are the same. I can also use the arcs in here to indicate, and aside from doing double arcs or triple arcs, I can also put a tick mark on the arc. So if this has one, and this has one, this has one, that means that they're all going to be the same measure. They're all congruent angles. Okay, so now we're going to move into classifying the angles. We can classify triangles two different ways. We can classify it by angle, or we can classify them by sides. We need to be able to do both, so we're going to talk about both of them. When we do angles, we're going to start with the smaller angle. So an acute triangle has three acute angles, so all three of its angles are going to be acute. All triangles will have at least two acute angles. An acute triangle has all three of them acute, which means that they're going to be less than 90 degrees. The next one we're going to talk about is a right triangle. You'll see a right angle, and it will only have one right angle. And again, all triangles have at least two acute angles, so the other two angles are going to be acute. When it has one right angle, it's a right triangle. Next kind is an obtuse triangle. It has one obtuse angle, and then the other two, again, they are acute angles. Obtuse triangle has one obtuse angles, and that's all we have to do for angles. So you just have to know what the angles are called, and then you can classify those triangles by that one angle that will determine it. The other way we classify them is by side lengths. If we see all three sides are the same, again, that annotation with the tick marks, each one has one, so they're all the same. That's called an equilateral triangle. It has three sides of equal length. If we see a triangle that shows that two of them are the same, that tick mark again, showing that they're the same, an isosceles triangle has at least two sides of equal length. Something that's really important in this definition is that it has at least two sides, which means that if I look at an equilateral triangle, it's got 1, 2, 3 sides. That's at least two. So every equilateral triangle is also an isosceles triangle, but usually if it's got all three, we'll call it an equilateral so we can be more exact. If it's only got two, we'll call it an isosceles triangle. And the last one, when all three are different, we call that a scalene triangle. It has no sides of equal length. We can also indicate that with tick marks if we wanted to, just to make sure we understood that none of these are the same. So none of them will have the same number of tick marks. Sometimes you'll see that too for a scalene triangle. So that's all there is to classifying triangles. Make sure you get each of these in your notes, and I would draw a little picture of each one to indicate exactly what they look like. So we're going to practice classifying real quick. So if you want to pause it, just try and classify this by its angles and its side length real quick. Go ahead and do that. and then I'll show you how. So go ahead and pause it if you want. If you're going to classify it by its angle, you'll recognize that there's a right angle here, and so all we have to know that one right angle means that it's a right triangle. And then if we want to classify it by its side lengths, we see that these two are the same, so it has at least two side lengths that are equal. That means that it's going to be an isosceles triangle. So there's a right triangle and an isosceles triangle. So that's how you classify these triangles. The last thing that we're going to look at is that the sum of the interior angles of a triangle are 180 degrees. So I'm going to do just a real quick demonstration of how that works. This is just a random triangle. And so I'm going to take all three of the corners that it has, all three vertices, and line them up for you. And so this is just a real simple proof that all three of these, when put together, will equal 180 degrees. And we know that they're going to equal 180 degrees because we see that they are all along this straight line right here once they're all added together. And so the sum of the interior angles of a triangle is 180 degrees. That's a really good thing to have in your notes also. The reason that that's important is because we can use it to solve problems like this, where we need to identify what this is, because I know that I have two acute angles, so two angles under 90 degrees, but I need to classify it by its angle, so I need to know what this third one is. If it's greater than 90 degrees, it'll be an obtuse angle, or an obtuse triangle. If it's 90 degrees, it'll be a right triangle, and if it's less than 90 degrees, it'll be an acute triangle. So the way I'm going to solve that, real simple equation. So I have x, and I know that the sum of all of them equals 180 degrees. So I'm going to add all three angles together. That's going to equal 180 degrees. So then I'm going to combine like terms. X plus 84, so the 42 and the 42 combine. That's still going to equal 180. And then I'm just going to do my one-step equation. So I'm going to take away 84 from both sides. When I take away 84 from this side, I get x. And this side, I get 96. And so I know that this angle measures 96 degrees. And that's above 90 degrees. So I have found the value of x. It's 96. And I'm going to classify it as an obtuse triangle. And that's it. That's really all the background knowledge you're going to need for tomorrow. So make sure you come in with some notes taken and you're ready to go. See you tomorrow.